Hey guys, so today we're going to be talking about something called capillarity. What is capillarity? So, have you ever noticed, say you have a pool of water? If you put a towel or a piece of paper in that pool of water, you will notice the water starting to rise up the piece of paper or up the towel. And this is what we call the capillarity effect, or simply capillarity. Capillarity is the ability of water to rise in small openings. So the smaller the particle sizes are in this piece of paper and this towel, the easier it will be for the water to rise up. Okay? So in our case, since we've been talking about sediments, the smaller the sediment size is, the higher the capillarity, or the higher the water will rise. Another word for capillarity is also water retention. And water retention is the ability of soil to hold on to water. So when I'm talking about sediments, here's what I mean. Say you have a little dish of water, okay, like this, and you have three tubes. One tube is filled with sand, one tube is filled with clay, and one tube is filled with loam, another type of sediment. Okay, you'll start to notice that the water from this container is starting to rise above these containers of sediments. Okay, and this is what we call capillarity, which is the ability of water to rise through small openings. And the smaller the particle sizes are for in each of my tubes, the easier it will be for water to rise. So in this case, clay is actually much smaller, the sediments, than sand and loam. That's why you're noticing that the water is rising much higher in clay. And the ability of soil to hold on to that water. So when that water rises, it will stay risen because of the soil, right? And how small the sediment size is. The ability of water to hold on to, sorry, the ability of soil to hold on to that water is called water retention. And the smaller the sediment size, the higher the water retention rate. The smaller the sediment size, the higher the capillarity. Let's write that down in your notes. Capillarity or water retention is the ability of water to rise through soil. And it's affected by particle size. Write that down as well. The smaller the sediments, the higher the capillarity. The smaller the sediments, the higher the water retention as well. So go ahead and pause this video and try question number 4. If tubes A, B, C were set up to test for capillarity, the data would show that capillarity is A, greatest in tube A, B, greatest in tube B, C, greatest in tube C, D, the same for tubes A, B, and C. The correct answer is A, greatest in tube A. So the capillarity is greatest in tube A because notice that tube A has the smallest particle size. The smaller your particle size is, the easier it is for the water to go up, right? And that's why it has a high capillarity or water retention rate. Go ahead and pause this video and try question number 5. Which graph best indicates the general relationship between soil particle size and the amount of water retention by a permeable soil? Remember, permeable or is another word for permeability, the ability of water to flow through soil. So we're thinking about how particle size affects the amount of water retention. The correct answer is D. As my particle size starts to increase, my water retention starts to decrease, right? And the smaller my particle size, so this is closer to 0, the smaller my particle size, the higher my water retention. And the larger my particle size, the smaller my water retention. Okay? Go ahead and pause this video and try number 6. Capillarity will cause water to rise highest in column A, B, C, or D. Now, this is not showing us the sizes of particles, but it is showing us the names of the types of sediments. We have pebbles, sand, and silt, right? And we have a glass of water. The water is rising. We want to know in which of these columns will the water rise highest. So to figure out the size of these sediments, you can go to page 1 of your reference table. Sorry, page 6. My bad. Page 6 of your reference table looks like this. And notice it tells you the sizes of boulders, cobbles, pebbles, sand, silts, clay right here. So to figure out which one has the smallest particle size, I look over here and I actually see that silt has the smallest particle size. Sand has a higher particle size, and pebbles definitely have an even higher particle size. So silt has the smallest particle size. Here's silt, D. That's why the correct answer is D. Go ahead and write this down in your notes. We can find some answers or the sizes of particles on reference table page 6 to figure out which one will have higher capillarity or water retention. And that's it for this video. We're going to talk about ESRT page 1 in the next one.